Hello students, welcome back to the channel. So today's topic that we are going to discuss is Gram-Schmidt orthogonalization process. So this topic is one of the important topic again. So don't think that every topic I'm telling as important, but the probability of asking will be more, okay, because this consists of problems in them. So might be a possible questions or a favorite question for the exam now. So without any further delay, let's see the definition. So given a set of linearly independent vectors, say v1 to vn, the Gram-Schmidt orthogonalization process, you have to find the orthogonal set of vectors, say u1 to un, as follows. Suppose they have given some vectors and you have to find the orthogonal set u for them. So the first formula, there are several set of formulas. The first formula is you have to find u1, say u1 is equal to v1. That is a standard formula for the first part. The second formula will be slightly trickier. You might find it a little bit difficult. So let me dissect it. Let me take it as u2. Suppose I take it as u2. So let me substitute instead of k, let me substitute as 2. So u2 is equal to, the answer will be k, right? So vk, right? So vk is what? v2 minus, already we have found out we have only one vector, we are only one set of orthogonal set, which is what? u1. So obviously it should be u1 into v2 divided by u1 into u1, and this goes on. This is never ending. Suppose I have asked, they say 3 vectors, then you have to find u3. So the process is never ending, and obviously in the exam they'll ask only for 2 or 3 vectors, but when you're solving for bigger problems, the vectors will be more. Anyways, the first problem is we are having 2 vectors, say v1 and v2. The first formula is what? u1 is equal to v1, which is 1 comma 1 comma 0. Okay, the first orthogonal set u1 is done. Now the second thing we have to find is u2. Okay, u2 is what? u2 is equal to v2 minus projection of u1 into v2. Okay, projection of u1 over v2, which is what? u1 into v2 divided by u1 into u1 into u1 into u1. All right, now this let us try to solve the projection part first. Okay, that will be easier. Once we find out that, then just substitute and get the answer. So u1 into v2 is what? We are doing the dot product. Okay, u1 is what? 1 comma 1 comma 1 comma 1 comma 0 into, what is v2? v2 is what? v2 is 1 comma 0 comma 1. Okay, now let us multiply. It is what? 1 into 1 plus 1 into 0 plus 0 into 0. So I'm getting the answer as 1. What is u1 into u1? u1 into u1, which is what I'm getting as 1 into 1 into 0. 1 comma 1 comma 0 into 1 comma 1 comma 0. Now let us multiply. 1 into 1 plus 1 into 1 plus 0 into 0. I'm getting the answer as 2. Now let us directly substitute. So I'm getting say u2 is equal to v2 is what? 1 comma 0 comma 1 minus what is u1? So directly substitute. So the upper part minus divided by the lower part, which is half, right? Half into u1. So 1 comma 0 comma 1 half into, what is u1? u1 is what? 1 comma 0 1 comma 0. Okay, I have forgotten to put the minus here, so please put the minus sign, guys. 1 comma, so first let me multiply. So yeah, here I have to put the minus symbol, minus. Yes, now let us do the subtraction. 1 minus half is what? 1 minus half is half. 0 minus half is minus half. 1 minus 0 is 1. Okay, so now we have successfully found out, for given vectors, say v1 and v2, we have found out the orthogonal set, say u1 and u2. Okay, u1 and u2. Therefore the orthogonal set of vectors, orthogonal set of vectors is what? u1 is equal to 1 comma 1 comma 0 and u2 is equal to half comma minus half comma 1. Okay, let us take one more example with three vectors, and let's see how to do it, because we will have u1, u2, u3. Okay, so the first thing is what we have to find u1 is equal to v1. Obviously this problem, they have not mentioned a Gram-Schmidt method. They have asked to find orthogonal basis. Okay, but we are using the method called Gram-Schmidt method to solve this orthogonal basis problem. Okay, don't get confused. In the exam they might specifically ask you to solve using Gram-Schmidt. Okay, anyhow you can solve, it's your convenience. Okay, the first thing is u1 is equal to v1, which is what I'm getting as, so anyways we have three vectors, so we want to find, say, for v1, v2, v3, we have to find u1, u2, u3. So u1 is equal to v1, which is what, 1 comma 2 comma minus 2. Now the first set is done. Now we have to find u2. U2 is what, v2 minus projection of u1 over v2 divided by u1 into u1 into u1. Okay, now we have to find the projection part first. Okay, u1 into v2 is what, 1 comma 1 comma 2 comma minus 2 into 1 comma 0 comma minus 4. So I'm getting 1 into 1 plus 2 into 0 plus minus 2 into minus 4. Okay, so it is what, 1 plus 2 1 plus 0 plus 8 is what, 9. Okay, now I'll try to multiply u1 into u1. So u1 into u1, right? So it is 1 into 2, 1 comma 2 comma minus 2. Similarly 1 comma 2 comma minus 2. So 1 into 1 plus 2 into 2 plus minus 2 into minus 2. Okay, so I'm getting the answer as 9. Okay, 9. All right, now let us substitute back to u2. So I'm getting u2 as what, v2 is what, same, it is 5 comma 2 comma 1 comma 0 comma minus 4, and minus, what is that, we have to numerator divided by denominator, that is 9 by 9. Okay, minus 9 by 9 into u1 is what, 1 comma 2 comma minus 2. Anyways it is 1, right? 9 by 9 is 1. So 1 comma 0 comma minus 4 minus 4 minus 1 comma 2 comma minus 2. All right, now let us try to subtract. 1 minus 1 is 0, 0 minus 2 is minus 2, minus 4 minus of minus, that is plus, that is so I'll get minus 2, right? Yes, so 0 minus 2 minus 2. Okay, now we have successfully found out u2. Now let us find out u3, which is the slightly trickier part. So the first thing is u3 is equal to v3. Okay, v3, the third vector v3 minus, now there are two projections we have already found out, which is what, u1 and u2. Okay, u1 and u2. Now you have to use both of these with the vector 3. Okay, so which is very easy, which is what, projection of u1 over v3 divided by u1 into u1, okay, into u1 minus projection of u2 over v3, that is what, u2 into v3 divided by u2 into u2. Okay, now it is fair and square, it is a straightforward method, apply and get the answer. So u1 into v3 is what I'm getting the answer as, u1 into v3 is what, so let me solve it. 1 into 1 comma 2 comma minus 2 into v3, 5 comma 2 comma 0. So I'm getting the answer as 1 into 5 plus 2 into 2 plus minus 2 into 0. So I'm getting the answer as 9. Okay, now u1 into u1 already found out above, so I'll write it directly, which is 9. Now let me find out the second projection, so that is u2 over v3. Okay, which is what, u2 is, so I'm directly writing it so that I doesn't lengthier the video. So the answer will be minus 4, and I will get u2 into u2, I'll get it as 0 into 0. Okay, this I'll get it as 8, if I am not wrong. Yes, 8. Now let us substitute. So u3 is equal to u3 is equal to 5 comma 2 comma 0, 5 comma 2 comma 0 minus what I should get, it's 9 by 9, so let's skip that, just write u1, so it is 1 comma 2 comma minus 2 minus 4 by 8 of I'm getting 0 comma 2 comma minus 2. All right, now so let me solve it. So I'm getting it is as 0 comma 1 comma 1. So yep, it is the answer is u3 of is 4 comma 1 minus 1 comma 1. So therefore for three vectors, say v1 v2 v3, I've got the three orthogonal set of vectors, say u1 u2 u3. Okay, so u1 u2, let me write it down. Yep. So this is that's all for the video, guys. So this is one of the topic that you can expect. So this is how you solve the Gram-Schmidt orthogonalization process. Thank you for watching the video. Thank you.